Welcome to the third and final online session for the Wildgrasses of Victoria course. Today, the objectives are, first, cover off the outstanding issues from last week. I gave you the exercise of trying to identify wallaby grass, a specimen of which I gave you the previous week. So I'll reveal what that is and find out whether anybody needs help and answer questions about that. Then I'm going to talk about recreating artificially grassy environments, a grassy woodland and grassland environments using horticulture. Then I'll talk a little bit more about management of native vegetation. I'll give you a couple of examples that elicit the essential principles to apply. I won't give you general formulas the way the Department of Environment, Land, Water and Planning does, because I think every site needs to be considered on its merits. But I'll give you the principles so that you can become a more nuanced and effective land manager if you want to be. I will then use whatever time is left to add a little bit more to your understanding of how to identify grass using the structure and other features of it. Normally in the third and final indoor session, when it's been in person, I give people loads of different grass species to identify using the keys. I bring a whole range of specimens from different parts of Victoria and elsewhere, and I give people in groups of 2 or 3 people usually specimens that suit their particular interests and go through them. I won't be able to do that, obviously. What I normally do is, whilst people are trying to identify them, I go from group to group and help them resolve any difficulties and find out what does create difficulties. That's very instructive for me, not just for the people. Hopefully it's instructive for the groups, but it also helps me tune the keys that you've got so that it bypasses the most difficult bits by using different characters for identification, and it helps me explain more clearly what to be looking for. Well, we can't do that, but I still hope to run a set of workshops which do the same sort of thing, with everybody sitting at a microscope. In 2019, I did that at the Field Mats Club of Victoria Hall, where everybody can have a microscope in front of them. And that worked really well. So you're missing out on something because of this pandemic and not being able to all sit in a room together. But hopefully that will, you'll have the opportunity to bypass that with an add-on workshop. I'm not sure whether that'll be at the start of next year, but sometime in the 12 months coming, I hope to be able to do that. So let's carry on with the follow-up from last time, or any other comments and questions you have. Anybody want to ask questions or make comments? See, that's one of the big differences with having these Zoom sessions. I don't get to see people's faces and watch them scrabbling through their stuff to see who actually does have something. That means that you're all very quiet and I don't get to see your reactions and respond in the way I normally would. But let's hope that you're not responding, not because you're half asleep and so on. Then I will do some follow-up. The main bit of follow-up from last time is that I gave you some homework. I asked you to read through any remaining parts of the notes with the kangaroo grass on the cover that you hadn't already read. If you've done that, then you'll be in a good position to get the maximum out of this session, because we don't have time to cover everything in those notes, as well as doing the things that really require me to talk to you. Some of the things in the notes are just as easy for you to read. There's a section there on taxonomy, for example. I'll leave for you to read that. There's a section on horticulture, and I'm thinking particularly of you, Andrea. I will cover some of that in just a minute, but some of it will, or some of the stuff in the notes is just as easy for you to read, so I'll skip over that. You'll also want to use those notes as follow-up, particularly as revision when we get to the grass flowering season next year, so that you can refresh your memory, a lot of which will have faded with terms such as glooms and lemurs and stuff like that during those many months when there aren't grasses flowering. So there is that homework, and I'll just remind you about that. Unless anybody has any questions that have arisen from reading the homework, I will then go on to the question of the grass that I gave you the specimen of, and ask you to have a crack at identifying using the key to wallaby grasses. Now, how many people actually came to a resolution? Maybe if you use the chat, we'll see how many people succeeded. Whether you succeeded or failed or were left uncertain, put something in the chat box for me so that I'll know how you're going. I know that some people won't have had time to do it. It's a busy time of the year, and partying is far more interesting than identifying a wallaby grass, I'm sure. But let me know how you got. Now, Ryan's got 2 options. Okay, Andrea hasn't had a go. Paul says specimen trashed by mistake. Okay. All right. We'll call this a failed bit of homework, I think. Okay, Andrea, sorry, Amanda can't remember what she got to. All right, you can keep putting your responses in there. I'm hoping that Emma got Ritidosperma cetaceum. Okay, and something further down. Okay, Matthew got Ritidosperma geniculatum. So we've got 2 contenders there, cetaceum and geniculatum, and some people who are non-committal or uncertain. Okay, cetaceum, we've got 2 votes for cetaceum. Sorry about the cetaceum people. It is in fact geniculatum, and that highlights what I mentioned last week, that the main place where people go wrong in the key is at that very first couplet. Oh, is it the first one? I better go through the key. I need to open that up, and I'll explain why it's geniculatum with the aid of some, well, I'll show you the floret under the microscope. Okay, my key is coming up. And I now need to share my screen. Okay. Yeah, okay. So the people who got cetaceum or geniculatum did get okay through the first couplet. They went to 1B, I presume. You can get to cetaceum with 1A, but I don't think in the pink fit you would have assumed that the floret looks like this diagram on the right for 1A with hardly any florets. So you would have gone to 8, I'm presuming. If I scroll down to 8, it says, okay, this is the critical point, 8A and 8B. Now, I'm going to show you a picture and we will see what you think, those cetaceum people, once you see the image. I'm just going to now stop sharing that, and then I have to share another screen with the microscope on it. Okay, here is one of the florets of the specimen that I gave you, and a couple of, well, here's what I would note immediately about this particular wallaby grass. Firstly, the seeds are hard to hold and look at the hairs because the central horn, the horn of the unicorn, if you like, is rather short. That's an important feature. In fact, there are the ears of the unicorn, or what we would call the lobes. Some books will call them the side lobes, but the lobes. And I'm noticing that the central horn is scarcely longer than the side lobes. That's an important feature. Another one is that if I were to rotate the specimen around, you'd see that there's no real bristle on the end of the ears of the unicorn. So the lobes have a tapering part, but they taper to points without bristles on the ends of them. Or if there is a bristle, it would be very short. Some of them have a really short bristle. So they are important features. The hairs, it looks at this sort of scale as though the hairs are scattered uniformly from this level to about that level. And if I zoom in, let's go to 60 times. Here we see it up close, so let's push it over a little bit. And you can see that there are indeed hairs scattered all over the face of the unicorn, or the body of the lemma, as they'd say. The terminology of this seed is, we call the whole thing a floret. In this case, the seed is a floret because it contains a lemma, this surface, the palea, which is around the back, so we'd have to look at the back of the unicorn's head to see that. And the lemma has a callus, which wraps around the little stalk that runs up between, or that joins the different florets together when they're all in the spikelet. So there is the callus. It's flattened. It's a bit hard to see there, but it's flattened and it stops at that point there. Then we've got a gap. This is what we would call the body of the lemma, between where the central horn joins on and the top of the callus. So we've got a gap in the hairs, or perhaps I should say the hairs at the tip of the unicorn snout, so to speak. You can see the tuft out the left and the tuft out the right, as all wallaby grasses have. The next level of hairs is up here, and in general there will be a row of hairs, but in some cases that row is very incomplete. In this case, it's incomplete, but it isn't just a row, it continues as scattered hairs, not in tufts, all the way up to some point around about there on the lemma body, as they'd say. So that's how I would interpret it. Now, with that in mind, we won't get down to cetacean, because cetacean will always have a definite bare patch between the row of hairs here and the uppermost hairs, which would form a row in cetacean. So we don't have hairs in three levels, the tip of the snout tufts and a row there and a row there. We've got tip of the snout hairs, and we've got a continuum of hairs scattered between this level and that one. I'll stop sharing that. Any questions while I share the key?
Just in regards to horn length, is that, so do you find you have to drop water on them quite often to get that measurement?
Not quite often. It's only in marginal cases. That may happen with Britridosperma cetacean and C. spitosum, both of which comprise multiple undescribed species. It's a real grab bag, particularly C. spitosum. C. spitosum you should view as not so much a species, but it's all those undescribed species that you can't put in anything else.
Yeah,
they do have a seed which is fairly consistent in most respects other than size. But when you look at the individual plants, there's huge diversity. There's clearly multiple species. It's just hellishly difficult to break them up into different groups. And I will deal with that once I've dealt with some more obvious undescribed species. Actually, one of the Britridosperma C. spitosums I will describe because it does really stand out. It's a foreshore species. It doesn't grow more than maximum I think I've seen is 1 kilometre, and that would only be because people have dragged it up from the beach. Generally, it's foreshore to 100 metres or so away from the high tide mark. So once you get to the very end of this key, you'll see cetacean and C. spitosum together. And near the end of the key, it'll ask you, well, there's a distinction on the horn length, and sometimes there are forms of cetacean that have longer than the usual horns, and C. spitosum, some forms have shorter than the usual, so they come really close. And if you've got one of those marginal ones, then it is worth putting the drop of water on it.
Mhm.
As I say it on the first page of these notes, it makes a difference of 10 to 25%.
Yeah.
It just depends on how tightly the horn is coiled on the particular species.
And if you're not straightening out the horn, would you sort of would you just, like, obviously usually the horn has a slight bend in it, and if you're running a ruler along that, you're not really accounting for that bend. Would you sort of measure it in two parts, or would you just measure it with that bend in it? Or
Ryan, I would measure it in two parts because I've got a nice dissecting microscope.
yes.
And if you're doing it with a hand lens, that will be difficult. Again, use the post-it note thing to hold them still while you're trying to do all this fiddling. But this species, people would have come to Geniculatum or cetacean based in part on the small size of the seed. So when you get down to this size seed, it's very fiddly. In this case, I reckon you would convince yourself, even if you didn't do it in two parts, that the lemma's central horn is less than the magic 6 millimeters, even allowing for the bend and the fact that you might be measuring without taking into account the bend. You might measure the hypotenuse, in other words. Yes, I am a PhD in mathematics. I think in most cases, it won't really matter. You'd be able to estimate adequately to avoid having to do it in two bits. But every home should have a stereo dissecting microscope now that you can get them for so little money. You know, a few $100, $200 or $300 will get you a quite respectable one. This is one of the disadvantages of not having you all indoors. Many of you won't have used a stereo dissecting microscope, or not for a specimen where the depth of field in the stereoscopic vision is so useful and amazing as on a wallaby grass seed or many of the other seeds of grasses. Wallaby grasses more than ever though, because when you have stereo vision, you see the depth of the hairs, and the measurements become so much easier. And here's a tip: if Father Christmas does bring you a stereo dissecting microscope, even if you take the role of Father Christmas, well, you can tell I'm old, Santa Claus if you like, then it's a good thing to invest in an eyepiece graticle or reticle. They're sold under the name reticle or graticle. I think probably more of them are under reticle. So if you go to eBay, you'll hear about this. I'm digressing, but the idea of a reticle is that it allows you to measure things to 0.1 of a millimeter without difficulty. You'll be amazed. I have one all the time on my microscope, dissecting microscope, and that would allow you to measure things to 0.1 of a millimeter easily. So Ryan, do the best you can with the materials available, and usually it won't really matter. Understood.
Thanks, Graham.
Okay, sorry for that digression, but it was a good prompt to cover off a few things that some of you might find useful. Okay, get back to 8A in the wallaby grass key. It says the lemma's central horn rarely exceeds 6 millimeters long and extends no more than 2 millimeters beyond the tips of the lobes, including the bristle at the end of the lobe if there is one. Pause. I'm thinking there isn't a bristle, so we just measure the length of those lobes. Well, sorry, we measure how far that central horn extends beyond the tips of those lobes, the ears of the unicorn, and I reckon it's clearly less than 2 millimeters. You may contest that. but you might not have actually put a ruler on it. Again, a 150 millimeter steel ruler that you would get from Bunnings. You can get them from Officeworks too, although yeah, some of those are all right. They will help you measure this sort of thing because it is rather tricky. So I'm wondering whether people who went to Cetacea might not have done the actual measurement. Now, the other bit after the bit in square brackets, it says there are dense hairs over the lemma body. I'm going to give that a tick. Whereas 8b says either the lemma's central lawn extends more than 2 millimeters beyond the tips of the lobes, including the bristles, or the hairs on the lemma body are in distinct rows with few, if any, hairs between the rows. So I'm going to take a punt that the people who got to Cetaceum, they probably thought, yeah, the central lawn might not be more than 2 millimeters longer than the lobes of the lemma, but that it appeared as though the hairs on the lemma body were in distinct rows. If that's the case, then that would take you down into the next stage, and because you've got small seeds and so on, you would fairly rapidly come up with Cetaceum. Oh, actually, it won't be that rapid, but you'll get there. Where's that? Yeah, there's a bit to go, but you would have come to Cetaceum. But I'm going to say that the hairs are scattered fairly uniformly over the surface of the lemma body, which would take me to 9. And 9a says full-size lemmas measure up to 3 millimeters, and you would have been asked the same thing for Cetaceum. So the Cetaceum people would agree, I think, that the lemmas are up to 3 millimeters long, with hairs rather even in length and density, and that was an important feature. With Cetaceum, the 2 rows, I'm ignoring the tufts of hairs at the tip of the snout of the unicorn, but the 2 rows have hairs of very unequal lengths. It's normal for those species that have hairs in 2 distinct rows for the lower row of hairs to be much shorter than the upper ones. And that's certainly the case with Cetaceum. Whereas in this case, they're pretty much even in length. There's a bit of variation, but not much. Then it says the coral part of the central horn is brown. I didn't point that out with the image from the microscope, but that was in fact true. So then you get to Ritidosperma geniculatum. So I'm going to stop sharing there. Now let's see, is there any comments in response to that? Did the Ritidosperma Cetaceum camp want to lodge an appeal? I see and hear no appeal. So I think I'd better move on because there's so much that I want to cover with you. It's coming in? No. All right. Then I will close that down. I'm going to show some slides now as we talk about creating an artificial grassland or grassy woodland. Okay. I'm not sure how many of you have an interest in revegetation to create or recreate native vegetation, but I'll show you a couple of examples where people have done just that. Here is an example from Alan Lodge, who did this course back in 2008, I guess it would be, because this photo says that, oh no, it would have been 2009, maybe 2008. One of those years, this elderly bloke, even more elderly than yours truly, did the course, and as a result of it, he decided he would revegetate this area. It was a former car park outside the Guild Guys Hall in, well, it's pretty much Laburnum next to Gardeners Creek. Because it had been used for parking cars for years, the soil was extremely compacted. Now, this is 2009. And you might recall that 2009 was the climax of the millennium drought. So you don't see much growing at ground level at all, hardly any ground cover. So between the drought and the heavily compacted soil, it was really harsh conditions. But Alan decided that as a result of doing this course, he would go out and collect seeds from in the parklands adjacent. He walked up to the left here and up the hill and collected a range of wallaby grass seeds and speargrass seeds and some poa seeds. He knew they were native. He wasn't too sure of some of the species, but he knew they were native, and he knew that they came from within a few hundred metres of this site, so that wouldn't create any environmental problems. So this elderly man potted around, collected seed by hand, and he sprinkled them over the ground. He didn't do anything else. He just sprinkled them over the ground. And after 2009, the following year, with the breaking of the drought and his spreading of the seeds, this was the scene. So this was after he'd done the course. He must have done it in 2008 or 2009, the course. And I was blown away by the success that he had. No cultivation, no weed control, just spreading the seeds over the bare ground at the climax of the millennium drought. And with the benefit of that amazing year for rainfall, the poas germinated. We have here Poa ensiformis in the foreground, and I can see some poas there. This sort of coloration over the back is all wallaby grasses, but we're not seeing many spear grasses there. I know there were some because I went and took this photograph, and there were the odd spear grass there, but they weren't really very conspicuous, and they weren't flowering yet. 2 years later, the drought-breaking rains were no longer there, but the vegetation had developed, and those poas in the foreground. Now, I might be standing one step further forward, which might be part of why the poas are not in the foreground. I think that's a poa there, and that's a poa there. I'm seeing a whole lot of wallaby grasses, and somewhere in there are some spear grasses, including Ostrostypa rudis subspecies australis, which is now listed as endangered. It was listed as rare at the time. This was pretty amazing, I think. Sorry, I shouldn't have gone to the next slide. So the Friends of Gardeners Creek, no, what do they call themselves? The Parklands. Maybe it is Gardeners Creek Parklands. My apologies to the Friends group and the Parklands. They got me to come out and have a look and let them know what I thought. They were very proud of what Alan had achieved with his walking stick and going around picking seeds by hand and all that sort of stuff, and to get such amazing results from a former car park with no pre-treatment or anything. And I went out there and met with them and said, yeah, I've been monitoring how it's been going for the last couple of years, and I think it's amazing what's been achieved. You've got a very high native cover, not much introduced grass, and I have a feeling the Friends group did some hand weeding through this process. And I said, but a couple of things. You've got houses over the other side of the fence there, and to the right of this photo, there is a property with the grass growing right up to their fence, and then a house in close proximity. And I said, although the fire risk is not that great, I think that if I were a neighbour, I'd be thinking, I'd like them to reduce the fuel loading there. That would be reasonable. And that can be done without any adverse consequences by cutting the grass, either slashing it or using a brush cutter. There are some shrubs that are in amongst it. So brush cutting for a small area like this would be an option. And if that were done after all the native species have had an opportunity to drop their seeds, there would be no real problem. The grasses would bounce back, and the wildflowers, not that there are many wildflowers in there, the shrubs would survive and so on. So you'd be keeping good relations with the neighbours and with the fire brigade. And some people look at something like this at summer and think, you know, it's just dirty. As CFA brigade people used to tell me back in the 80s when I was on a fire prevention committee. The other thing is, it's got lots of grasses, but it doesn't have wildflowers. And here's another thing that you could score points with the Girl Guides, for whom this is the car park and other park users. If you were to plant things like bluebells, chocolate lilies, some everlastings, things like that, to add colour and diversity, you would not only make it look nicer, you'd have a more fully functioning ecological system, and it would be a little more robust to change. So I encourage them to plant some wildflowers in there, and tube stock would be an option, and spreading some seeds of the species that can come up from direct seeding would be an option as well. And I must go back and take some photos of how it is today. I say that every year, and I haven't been back there to take another photo. I have been back there since 2012, but not for some time. So that's the end of the slides on that. Well, I was going to invite comments. What's the comment?
Given the openness of the vegetation in there, I mean, even a low intensity burn would reduce the fuel load as well and stimulate some growth as well.
Yes, that's certainly true.
And probably, and then if you've got those other seeds you could chuck in there, they might stimulate them to grow as well.
That's probably true as well. If they've already got the wildflowers there, they may be reluctant to burn, but our native wildflowers in an area like Blackburn are they've evolved to well cope with fire. And the low intensity burn here would do the trick. Depending on the time of year, it would raise the prospect of increasing the abundance of the annual grasses. There are, or were when I was last there, some annual introduced grasses there, like the Vulpia species, and I can't remember specifically, but there might have been a few Era species, the silvery hair grasses. The reason why they aren't really taking off here, I would put down to the compaction of the soil as harsh conditions for an opportunist species. Opportunists, like annual grasses, really like to have good growing conditions with not much competition, and compacted soil doesn't suit them, other than that in most cases, compacted soil doesn't have many native species growing in it either. But in this case, there's plenty of native species to provide competition. If you were to burn, then you would expect things like sweet vernal grass and Vulpia species to be in larger numbers. So whenever I contemplate a burn, or whenever I'm asked about such a thing, I say, if you do the burn, make sure you schedule a bit of time to do the follow-up, because it may require some follow-up to remove the annual grass weeds come next October or thereabouts, October to November. Any other questions or comments?
I've got a question, Graham.
Yep.
When doing sort of urban or peri-urban native grasslands, do you feel like ecologically it's more sound to put more wildflowers than grasses? Because I feel like grasslands, to be ecologically functional, you need a really big area of grasses. But I feel like wildflowers are more efficient in terms of offering food for pollinators and so on.
Well, they offer food for pollinators, but you know, grasses provide a huge amount of food, and they form the base of the ground cover food chain. If you think about the fungi, the insects, the skinks, and so on, there's huge biodiversity that we just don't pay much attention to. Yes, pollinators on a flowering shrub we notice, and there is some diversity there. There's insect pollinators and some birds pollinators. So yes, having some wildflowers, shrubs will certainly encourage some additional species, but don't write off the value of grasses. And as I mentioned earlier on in the course, in a situation like this forest or in a grassland or a grassy woodland, the grasses are providing, well, they're doing a lot of the photosynthesis. In this photo, you can see the trees, and they are doing most of the photosynthesis, and hence the primary production that an ecologist like you, Gil, know all about. Primary production, taking the energy of the sun and converting it into starches and sugars that form the base of the food chain for all the fauna higher up the chain, and also push the organic material into the soil on which all the other plants, including those wildflowers and their pollinators, rely. So wildflowers are good to include, and that's why I recommended them here. But I think if you want to have a system functioning better, you do need to have a substantial cover of grasses as well. It depends on what the rainfall is in Victoria as to the proportions. So higher rainfall areas, you'll usually find a larger fraction of the ground cover in terms of projected foliage cover, and hence photosynthesis, will be in the grasses. Whereas if you go to some dry areas, you'll find that wildflowers can be a large fraction of it. If you go up into the Alps, you find grasses are a very large fraction of it, but you've still got lots of wildflowers. So there's a bit of variation in the proportions that occur in nature, and you're not tied to mimic what happens in nature, but I think it's a salutary lesson to know what happens in nature, and if you're aiming to have, well, to serve nature's purposes, if you were to just go for lots of wildflowers and not many grasses, that's not the way nature has evolved to cope. And so I think overall you'll probably do better for nature if you have a good balance between them. And grasses are easy to get to go too. So in this case, at the Parklands in Blackburn, in this old car park, grasses provided that, I would call it an instant cover, an instant addition to the organic material of the soil. And it's formed a good framework within which the wildflowers can occur. Mm-hmm. How do you respond to that, Gil? Does that sound reasonable?
Yeah, definitely. Yeah, I just feel like there's a little bit of a trade-off between making it aesthetically attractive to people who don't understand how it works and making it functional. There's a little bit of a...
There's also an education process too.
Yeah.
I think in this particular case and in other cases, you might find that if you've got a degraded site, that the grasses are the initial easy to get in, establish, and then you can start planting the wildflowers in amongst them, as Graham was suggesting before. Mm-hmm. Particularly if you've got a slope here that need, there's a bit of moisture variation, you'll get stabilisation of the ground quicker. Mm.
Any other questions or comments before I go on to the second example? No? Okay, then I will do just that. The example is from the Growling Frog Golf Course, which is, now somebody will probably correct me, it's about Yan Yean, but I think it's not actually Yan Yean. What would be the locality there? Can somebody tell me? I drove past it 2 days ago. Anyway, it's out that way. You can see Donnybrook. Okay, yeah, Donnybrook sounds about right. It's out that way. And you can see in the background here the River Red Gums on flat terrain, and they are big spreading River Red Gums, indicating a grassy woodland as the pre-European vegetation of the area. Now you see a couple of blokes standing there. One's Tim Connell from the city of Whittlesea, and on his right is Chris Finlay from Flora Victoria, which is a producer of large quantities of native grass seed for using in revegetation projects, principally in the suburbs to the north and west of Melbourne and down towards Geelong, that sort of area. And this is part of a project. The golf course was being created, and in order to get a permit to remove some native vegetation, they needed to achieve some offsets. One of the facets of the offsets that council required them to do was to create an artificial native grassland. There are no remnant trees in this area. So an area of 50 metres by 50 metres roughly was fenced off, and the objective was to create an artificial grassland. The first thing that was done is that the ground was sprayed with herbicide 2 or 3 times, I can't remember, to kill all of the grass seeds. And if that wasn't enough, the topsoil was removed to a depth which you can sort of make out by looking at the boots of those 2 guys there. I think it was about a 10 centimetre layer of topsoil was scraped off the top with an excavator and trucked away. And that's pretty expensive. And the purpose of doing that, well, there are 2 purposes. One is that topsoil that's had superphosphate and potentially other fertilizers added to it makes the ground more fertile for introduced species. That's why it's been used, but our native species are adapted to the original level of nutrients, and Australian soils are notoriously low in phosphorus. So it is common practice in a revegetation project to commence by weed control, which Allan Lodge didn't do, and by removing the topsoil, which Allan Lodge didn't do. So this is the standard sort of technique that we're looking at here in this photograph. The ground was then cultivated, not very deeply, with a rotary hoe. I think that was unnecessary, and Tim Connell, who oversaw this, the guy on the left there, concluded that it was unnecessary in the end as well. So, as it says down the bottom there, scalping, cultivation, weed control, and then the sowing. Chris is there because he's brought all of the seeds that have been growing in his company's seed production area, or SPA. You'll see in this line of work the abbreviation SPA coming up a lot, seed production area. Flora Victoria has an area of, what would it be, a couple of hectares, I suppose, with row upon row of different species of grass that are grown, a lot of it under contract, where the seeds have been collected from a particular spot. And if you start off with a small number of grass seed, you can multiply them up by a factor of 10,000 or more within 12 months. So that's what they do. They collect vast numbers of seeds, and seeds were collected from around this area and grown, so that a year or 2 later, Chris had a truck with all of these seeds that had been collected. I won't go into the process of collecting the seeds unless anybody's particularly interested. Oh, Andrea's there. I better tell you that they have their own brush harvester, which goes over the grass, and it uses big brushes to brush off the seeds into a collection vessel on the vehicle. And a fair bit of effort's been put into devising these machines, to the headers, to collect the seeds. So I can't remember whether a ute was used on this occasion, but I've certainly seen situations where the seed is in big bags on the back of a ute, and there is a big fan and some ducts out the side, and the seeds are blown out the sides and the back of the ute, as the ute drives along, spreading the seeds over the ground. And that is what was done. One usually aims for a density of seeds of around 1,000 grass seeds per square metre. That's a good benchmark for the number of seeds that you need. So the seeds were spread on this site, and around the same time, a kangaroo-proof fence was put around there, partly to make sure that the grasses would be able to establish well, and partly just to see how well in the longer term the native, well, the artificial grassland would respond in the absence of kangaroo grazing as compared with the progressive grasses outside the fence where they have the grazing. So having just sown the seeds there, the following day there was a howling gale, and Chris thought, oh crikey, all of those seeds that had taken all that time to grow are going to have blown away. But when he went and checked, the seeds were still all there. As you'll see in the next photograph, quite adequate, were still there to create a good cover of grasses. What had happened was that the wallaby grass seeds and the spear grass seeds and so on had already lodged themselves in the soil, bearing in mind that the ground had been rotary hoed, so that probably made it a bit easier for them to do so. Okay, now this photograph doesn't have a year on it, does it? Unless it's up the top and I can't see it because of the thing. Oh yeah, June 2008. Now I can see it once I move that little bar out of my way. Okay, so that's June 2008. It's getting, 2008 was an incredibly dry year. I think it might have been a record dry year. The following year was even drier. So here we are, and this is, I'm going to have to remove that bar. Okay, October of the same year, a very dry year, and this is a mosaic of photographs, and so the mosaic is not a perfect thing, but you can see the green tinge. There was some rain by October. I have a feeling that we didn't get an autumn break. We didn't get decent rains until about August. But anyway, by October, the seedlings have germinated. You can see that cast of green over the landscape. The next month it looked like this, and I'm amazed that it did that. Now we're looking in the opposite direction. The photograph was taken from a different direction. I think Chris took this photograph as he did, as somebody there did earlier, the other two photographs. And what species do you see there? Lots of wallaby grasses. I can see Richardosperma. I think that one's Cespitosum there. That might be fulvum over there, I think. I'm seeing lots of wallaby grasses. And if I move this nuisance bar out of the way, can I see any spear grasses? No, I don't see much diversity. I see lots of wallaby grasses. Ah, now if I move that, I do see some spear grasses. Those dark coloured vertical bits are spear grasses, but there aren't many of them. There were spear grass seeds in the mix, but not much of it flowered that year. So that was November 2008. Here is the subsequent month, and again we're seeing lots of wallaby grasses. Now I can see these rather wavy bent over stems. That'll be common wheatgrass, Anthocyanne scabra, but overwhelmingly it is wallaby grasses, and that's because wallaby grasses are really effective as opportunist species. They persist indefinitely, but in smaller numbers than in the first year or two following the denudation of the landscape by a fire or a flood or an excavator scraping off the topsoil. So wallaby grasses have done the main part of clothing the ground, stabilising it against wind erosion, all that sort of stuff, and starting that succession that involves photosynthesis and putting organic material into the soil, providing the starches and sugars in their foliage and seeds for insects and lizards and that sort of thing to move back into this system and get the whole ecosystem starting to function. So that's December 2008. And although I think that might have been a record dry year, 2009 was an absolute shocker for those of us who can remember the climax of the Millennium Drought. It's the year of the, actually 2009, the earliest part was a shocker. And by the end of the year, the very end of the year, we got some rain. And evidently there was enough to allow some flowering. And so in 2009, we still see loads of wallaby grasses, but we see a couple of different species of speargrass now. That's because speargrass are not the early colonizers, the really opportunistic species. They're a bit slower to get underway. At least there are some speargrasses that are opportunist early colonizers. Ostrostipes scabra has that role. So I would always include some Ostrostipes scabra in revegetation of this kind if it's a locally indigenous species. So we see, I reckon this will be Ostrostipes semibarbata there, looking at the shape and size of the inflorescences. This, I'm not too sure what's going on there. Anyway, so we can see a little bit more diversity by 2009, and 2010 we had that spectacular year, and unintended, it was found that the excavation had ended up being not completely flat. I mean, this is a really flat landscape, and when you put an excavator on there to scalp or scrape the top 10 centimetres roughly of the soil, the excavator inevitably is not going to leave a completely flat surface. And there were some depressions, which ended up being ephemeral wetlands. That is, little depressions that have water sitting in them during the wetter months of the year. So in 2015, a whole mob of people like me were taken out there to have a look at how the project was going. And so we saw that the bulk of the area has this cover of wallaby grasses and spear grasses, and we saw in the depressions that some juncuses had volunteered themselves. I'm going to show you a whole range of juncus species from different groups tomorrow. These are the so-called leafless rushes. That might be Juncus secundus, I'm not sure. There are a few species that look quite similar. So I can see a few juncuses there. I can tell you that there are some carex species there, the true, or sedges in the narrow sense, in the genus Carex, and a few other little juncuses like Juncus bufonius had volunteered themselves. So they have some species of plants volunteering themselves, particularly in the wetland, because they didn't plant any wetland species other than Ritidosperma duttoniana might have been in there, I think, and that would have done very well in the wetter patches. By 2015, it had been realised that just sowing grasses was not really enough. So it's very similar to the Blackburn situation, that they had great success in getting grass cover, but they hadn't paid any significant attention to the wildflowers initially. And they had realised that that was a shortcoming, and they had planted some wildflower species, including some threatened species and some that are quite uncommon. One of the threatened species, I think, was the species that's now known as Xerochrysum palustri. It's only recently described. I don't think it would have been described when the original project was started in 2008. It's a wetland fringe species and an ephemeral wetland species. And I think that's been planted in here. And bluebells and chocolate lilies and everlastings, things like that, I think have been planted in there. So we have now a quarter of a square metre, 50 metres by 50 metres. At least that's what I was told, although it looks like it's larger than that. And my recollection is that it's bigger than that. But anyway, I was told it was 50 metres by 50 metres. Kangaroo exclosure fence, which also would keep out the predators, or at least most of them. So this area could be used for reintroducing something like eastern barred bandicoots with a bit more attention to the predator exclusion. And it's fulfilled the function of the offset. You know, most offsets that are created for compensating for destruction of native vegetation never achieve their goal. There's only been one serious attempt to determine whether the goal is achieved, and it was very clear that it hadn't been achieved, and that's certainly been my observation. But in this case, this sort of, well, this particular example of an offset had achieved its goal of achieving the cover of native species, and it's providing some habitat for certain fauna. There have been lizards recorded in here. I don't know about snakes and other things, but it's certainly providing some habitat, particularly for insects. And with some additional wildflowers that will be providing habitat for pollinators and that sort of thing. Or you can also see the logs that have been put in here to provide habitat for reptiles and lizards and all manner of invertebrates such as centipedes and so on. So some attention has been paid to providing additional wildlife habitat. So it's worked, and it's more expensive than it needed to be, except that this was a demonstration project. Nobody had done anything quite like this, and City of Whittlesea was certainly keen to find out just how well it worked. That's partly why it was that small an area. It obviously had more value if it was larger, but because they really wanted to see what could be achieved, the project was designed so that it wasn't huge and it was more expensive than it probably needed to be, other than they really wanted to see how well it could be made to work in a test case. So in previous courses, people have quite reasonably wanted to know what the cost of it was. So here is the costing. The fence, well, it must be more than the 200 metres because the scalped area was 50 by 50 metres, and if the fence had been right around that, then that would be 200, but I know that there was about 10, 20 metres surrounding that, so it'll be more than that. Anyway, $4,000 for kangaroo fencing. In many cases, you won't want to use that, so that would be a saving. The soil scraping and rotary hoeing was $2,000. The rotary hoeing was probably unnecessary. The seeds, to have them collected, or the original seeds collected for them to be bred up in the seed production area, harvested, brought onto site and spread over the ground, cost $3,145. A lot of effort was put into weeding in the first year, and that included hand weeding even, and all of that cost $5,800. That might not have all been necessary. And Tim Cole put in his own time to spread some smoke water, and I think he raked in the seeds, and that was just something he wanted to do. So there was no cost involved in that other than the cost of the smoke water. So all up, that came to around $18,000 for the whole project. And if we call that half a hectare, it was half a hectare, so it mustn't be more than 50. Yeah, all right. I think Tim probably got the 50 metres wrong. Half a hectare sounds more reliable, because the half a hectare is also what he gave me, and he calculated that it worked out to about $7 per square metre. And he said that that is quite competitive with other sorts of vegetation that would be required under a landscape plan for any average suburban residential development. He hadn't done the calculation for if it had just been turf, but he suspected it wouldn't be a lot more than if turf had to be laid and nurtured through its first year as well. So the conclusion from Tim at City of Whittlesea was that the project was a success. They learnt a lot from it. In future, they didn't need the full list of expenses there. Kangaroo fencing usually wouldn't be necessary, nor would rotary hoeing and so on. And weeding was more than you would probably need, so you could probably bring the cost down to half or less than of the $7 per square metre, and that makes it quite affordable, he concluded, and I think I would agree. So that is the end of that example. Does anybody have any questions or comments?
Yeah, Graham.
Go ahead.
I was wondering, how did he decide that the rotary hoeing was sort of unnecessary? Like, what made him think that? Because I imagine the soil still would have been quite compacted.
Yes, it probably would be compacted, but you saw what happened with Alan Lodge's project. Native grasses tend to do quite okay on compacted soil. Introduced species certainly do not. There would certainly have been less introduced species establishing had the rotary hoeing not happened, but then some seeds might have blown away in that windstorm straight after they were sown. So there are some pluses, but there's also some minuses. One of the reasons for thinking that rotary hoeing is not really necessary is that there have been now quite a few projects where there has been no cultivation and the results have been good, just as good as this. So you can do it, and you probably will get more rapid growth, and you probably, well, yeah, you can probably achieve a result faster, but you'd also have more weeds established and so higher costs. So there will be some cases where it's worthwhile doing and some cases where you might as well save your money, I think, Emma.
Yeah. We've done our own direct seed project with Flora Victoria as well. And that was scarified a few times before the seeds were sown, and it was sprayed out for like 6 or 7 years before the seeds were sown.
6 or 7?
The weeds were intense. This is like disused farmland and a little bit of fill, sort of, and beneath that was supposed to be basalt soil. And yeah, the wallaby grass have come really good. We haven't seen too many stipers or Bothrochloa or Dicalacne, I think was also in the mix. But the weeds are still pretty relentless. So I wonder if that was because of the scarifying.
Yeah, well, that's a good point. So you're with City of Banyule, right? So whereabouts was this case?
Banyule Northern Grasslands Reserve along the Darebin Creek.
Okay.
Yep.
Yes, it is hellishly weedy along there, isn't it?
It sure is.
Spanish thistle, artichoke thistle, and that sort of thing.
Yeah.
Well, I wonder if scarification did provide an extra advantage, particularly for the daisy weeds. Are daisy weeds like those thistles part of the problem?
Yeah. We've had heaps of thistles. We've got a few patches of Breezer Major, and a few Phalaruses and stuff have popped up as well.
Okay.
Yeah.
Well, I wonder, it would be really good to have more controlled experiments. And if there'd been adjacent patches, one of which, well, as a scientist, I like to see replicates. So what one would ideally do is mark out an area into a series of plots, and some of them would be treated the way you've described, and some of them would be treated without the scarification or light cultivation.
Yeah, definitely.
Some of them would have other variations that you might want to explore the importance of. So that would be really good. And then we have a clear idea of whether the scarification was a net benefit or a net disadvantage.
Yeah, we also had heaps of blown grass pop up as well, which wasn't supposed to be in the mix, and we don't have too much of it around here either. But yeah, a lot of blown grass in it.
So you didn't mention scalping or scraping the topsoil.
No, yeah, we didn't do that.
Oh, okay, right.
Yeah.
Okay, there's part of the problem.
Yep.
Again, it'd be great to do a controlled experiment.
Definitely.
Oh, and when I say controlled experiment, the control would be amongst those patches that I just described. Some of them you do nothing. Yeah, so the reason for scalping the topsoil is to remove the nutrients and the weed seeds that are in the soil, which wouldn't include things like the Spanish artichoke thistle, but it would remove seeds of Phalaris aquatica, for example, the Toowoomba canary grass that you said was still a problem. So that would have been a lot more beneficial than scarification. If you only had the money to do one or the other, I would say, well, I guess the scarification is probably cheaper.
I think they were also worried about running into the basalt rocks as well with scalping.
Yeah, but you'd also run into that with the scarification.
Yeah, true. Yeah, you're right.
So yeah, that's a very valid point along the banks of Darebin Creek there with the rocks.
Sorry, the running of the basalt rocks underneath would provide you with a microclimate around the rocks because you get water and heat from those. So you might get different things growing up around it.
Yeah, that's true.
Yeah, there's certainly a real benefit for adding diversity of flora and fauna, but it does raise that practical problem of how do you properly scalp the ground when there's a large number of rocks.
Yeah.
So yeah, it could be a bit of a drag.
Yep.
But you know, farmers on the basalt plains have coped with that over
that's
vast
true.
tracts of land. So even if it was a matter of having machinery like an excavator that does the scalping when they come up against a rock to, if necessary, remove the rock, put it aside, and once the scalping's happened, put the rocks back.
Yeah.
That might be an approach. And of course, that's going to be more expensive than on a site where there's no rocks. But yeah, the rocks, as Paul said, are a real asset from a biodiversity point of view.
Oh, for sure. Definitely.
Yeah. Okay. Well, that's a good contribution, Emma. Thank you for telling us about that.
Yeah. Yeah, it's only in its first year, so hopefully once the Xanthonia produces more seed and stuff, it'll outcompete everything else. But yeah, we'll see how it goes.
Yeah, it'll compete them to some degree. I hope the osteostipers take off, and kangaroo grass over time will certainly thicken up. I'm surprised that the red-leg grass, or Bothriocloa macra, and the silky bluegrass, the Dicynanthus sericium, didn't take off because they're good opportunist species. They normally relish that sort of situation.
Oh, hello. Sorry.
Okay. Let's see. The only other comment I was going to make is that 6 or 7 years of weed preparation with spraying and so on is unnecessary. If you haven't got them under control within, say, 2 or 3 years, then you're probably never going to have them under control adequately to avoid the problem that has ultimately arisen. So I'd say get it under control in maybe your first year, then do your scalping, the removal of the topsoil, then do some weed control, maybe a couple of sprays a couple of months apart, depending on the time of year, and then that should deal with the weed problem much better than waiting for 6 or 7 years and all that chemical use and so on. That would be my expectation. Any other questions or comments?
If I may.
Yep.
I actually worked at Flora Victoria for a number of years, and I did that manual job at some point as well. So it's interesting to hear the outcome. But just on the topic of cultivating, I know Flora Victoria use a cultivator that only goes maybe 5 or 10 millimeters deep, as well as encouraging the native grasses to grow. Another sort of like really important point of doing that is to encourage the weeds to grow. So they cultivate it a couple of times a year to make the weeds grow, to then spray them. But yes, I didn't know that project actually took 7 years of spraying, and known the difference between projects that generally a good restoration project should only take about 2 years for grasslands. If you end up spraying them longer than that, I think it's about poorly timed weed control. So people are obviously leaving it for too long, having to spray it again. And I've seen sites that have had, 6-7 years of chemical spraying and then sown, and it doesn't work because I think the chemicals, I'm sure you probably able to know more than me, Graham, but they change the soil profile and sorry. And yeah, when you sow it, you tend to get lots of really nasty weeds once you put a lot of chemical in there.
Well, that's really useful. Thank you, Corey. Yeah, so I have a lot of respect for Chris Fendlay and Graham Hoxley, who they're the partners in that business, Flora Victoria, and the idea of such a shallow 5 or 10 millimeter depth cultivation, that does make some sense to me. Yeah. Whereas rotary hoeing is obviously much deeper and I think less constructive.
Yeah, I don't think it's necessary.
Yeah. Okay. Oh, well, that's very good. What you've said, Corey, accords with what I was saying before. It all makes sense. So I think we can interpret that Daniel example fairly well now. Good. Okay, time is marching on, but if there's another question now, I'll take that before we move on to management. Otherwise, this is pretty much the end of revegetation. Oh no, I've got one more example of revegetation. No, okay, then I'm going to move on. Some of you will know, oh, mine's going blank, Grassy Ground Cover Project, Gibson Roy. Surname Gibson Roy, what's his first name, please? Oh, none of you know him. Okay. Oh, it'll come to me.
Says Paul on your screen.
Oh, okay. See, I can't see all my screen because I've got your happy faces in front of me, and I've got this bar here. Thank you. Paul Gibson Roy it is. Yeah, okay. Led by Paul Gibson Roy. Okay. Maybe I've got to set up a second screen on this little computer so that I can see things unimpeded. Okay, Paul Gibson Roy had as a PhD project at the Burnley campus of the University of Melbourne, the old Burnley College, the task of trying to perfect or to establish a new, more effective way of establishing native grasslands. And the principles he worked on were building on that approach of scalping the topsoil off the ground to provide a surface for revegetation that doesn't have unnaturally high levels of nutrients and that doesn't have so many weed seeds in it. But rather than take the approach that Alan Lodge took at Blackburn and that City of Whittlesea and the associated people took at the Growling Frog Golf Course, or at that Banyul example that we've just been hearing about, he worked on an ecological principle that is a bit similar to what Gil was saying, that if you add more wildflowers into a system, then you're going to provide habitat for more species. But more than that, if you were to choose wildflower species that have different habits or life forms, such as rosette forming species, so similar to a flatweed, I guess, but you'd be sowing natives with the same sort of habit or life form, and different flowering times, and trying to maximize the diversity within the wildflowers. I can't remember whether he included flowering time. That would be another obvious thing to include. So what he did is set up some trials, and they were scientific trials, controlled trials, looking at how things went if you scalped the ground, did your weed control, and sowed with mixtures of, or different mixtures of grasses with different sorts of wildflowers. And it's all become a bit hazy in my memory as to exactly how he set up the different situations. He conscripted a whole range of farmers around the Western District, particularly, and up into the Wimmera, who were prepared to have paddocks treated this way. And he demonstrated that by having this diverse range of life forms in the mix, he was able to establish a system which was working better ecologically. And I wish I could remember more of the details in the conclusions. I better go back and read his thesis. Incidentally, all theses from University of Melbourne, and most universities these days are available online. So I should be able to find his thesis and read the conclusions section to find out exactly what he demonstrated. But it worked well enough that it set him up for a career in this sort of thing. He went on to work for Greening Australia and then was poached by the New South Welsh people and is now working up there. He was when I last heard, so I presume that's still the case. But in this photograph, you see an example of a, not a trial, so, well, sort of a trial, but not one of his research trials. Vic Roads had paid him to create some roadsides using this technique of a diverse range of different sorts of wildflowers as well as different grasses. You can see a road above right here, and this, I would say, from my experience of doing ecological surveys and botanical surveys on huge numbers of roadsides and rail reserves, this would be the worst possible place to try expecting or to expect native vegetation to survive. That's because the road is above grade. That is, it's been built up above the natural surface of the ground, which means that all the runoff from it runs down into this area. All the weed seeds that come along the edge of a road will be washed down into this area. I guess this is a rural road, so there's not so much problem with runoff of oil and so on into the adjacent land. But it's a general principle that when you survey along a road, you go pretty quickly through the parts that where the road is above grade, and once you get to a section with a cutting where the road is below grade, you get much better quality vegetation. So this is a particularly difficult part along this roadside, and it had been treated. You can see the edge there where the topsoil has been scalped, as they say. And I don't know quite how long after the sowing this photo was taken. I think it was probably a year or so after it was done. And again, it'd be great to have a time series such as I had for the growling frog example, or the Blackburn parklands example. But as you can see, it's established very nicely. It looks really nice. It's got a range of different grasses and wildflowers. So it can be done, and it'd be nice to be able to prove to you that it can continue to remain in this sort of shape over the years, despite being in the worst part of the landscape for a roadside patch of vegetation. And that's the only photograph I've got from the grassy ground cover project, but you will find online a whole lot of reports and information about the grassy ground cover project, which comes under the auspices of Greening Australia. Does anybody have any questions or comments on that? No? Okay, I'm just going to check the time. Tracking well. And that means that I can stop sharing my PowerPoint, and that really is the, oh, no, it's not. I shouldn't have stopped because there is still more. That is the end of the stuff to do with the revegetation and those related horticultural things before we go on with managing of native vegetation. Does anybody have any questions at all on horticulture or revegetation type stuff? I'm not seeing anything, so I'm going to go on with the management. Okay. There is a section in the notes with the kangaroo grass on the cover that deals with management. It's not detailed because, as I said, each site needs to be considered on its merits, and that means considering history of the site, all the flora species present and the fauna species, and what time of year you can do things, which times of year you can't because there's some rare plant flowering, or that the rare swamp skinks are active, that sort of thing. So I won't give you standard prescriptions, but I'll show you some examples that illustrate the general principles. And here is the first one, Fairbairn Park, Mount Martha. Before Mount Martha became much more residential. Fairbairn Park is just an amenity reserve with some remnant vegetation in it, but not the natural sort of native vegetation. It had been completely cleared and then allowed to regenerate, but with hardly any of the original coastal manna gum eucalypts that used to be there. And instead of having the heathy manna gum woodland that used to be there, heathy because it's sandy soils and the nutrients leach out, dense Banksias. This is Banksia marginata, I think, coming up here. It came up really thickly, and so did Garnia radula. And for a council amenity reserve, having a thicket of Banksia wasn't the go, so it had been managed for many years before I got there by slashing about once or twice a year, in most years, in between tongues and islands of the dense Banksia regrowth. So it forms a matrix now with expanses. It's like a maze, actually, where you can wander through the grassy areas, but you can't penetrate through these tongues and islands of the Banksias with dense Garnia radula or thatch sausage underneath, which I showed you out at Montrose last Thursday. And you can see that the grassy areas are dominated by kangaroo grass with its rusty brownish colour. And you can see green underneath, which is partly kangaroo grass, but it's also got lots of other stuff. If we look below the canopy of the kangaroo grass, it looks like this. You can see kangaroo grass there, and this is an area where the kangaroo grass was a bit thinner, but if you look down at ground level, you'll find that there are some introduced grass species, like I can see here the seed head or inflorescence of a silvery hairgrass, an era species, but overwhelmingly I'm seeing wildflowers with yellow flowers. That would be mainly Gardenia lanata, but I can also see Hypericum gramineum there with a yellow flower. There are some blues, like I can see, now that's either, I know what's there amongst the blues. It's either a bluebell, which I think is Wallenbergia gracilis, the slender bluebell, and loads of Thelomitra, and under their current nomenclature it would be Thelomitra paniculata. And there's also a whole lot of Pattersonia occidentalis in much of the area. Now, if I move the bars, maybe I'll be able to see a Pattersonia in flower. No, I'm not seeing one, but I can tell you there are Pattersonia occidentalis there, which provide beautiful blue, purple flowers. We'll see some of those tomorrow, I expect, at Bungalow Conservation Reserves. If the weather
a whole lot of Mycotis in there too.
Thousands. What's that, Paul?
A whole lot of microtus in the centre.
Oh, yes, good point. Yeah, there is Microtus parviflora there. And I can't tell it's parviflora from the photo, but I'd be pretty sure that in this situation, it would be parviflora at this site. So there's Microtus there. There's loads of Microtus, loads of Thelomitra. And the more you look, the more wildflowers you get. It's actually quite diverse. So what we have here is a completely artificial sort of vegetation that is missing its eucalypts, that the structure is completely changed and the proportions of the indigenous species are completely changed. But it is overwhelmingly indigenous plant species. So if you value things for having indigenous plants, then it ticks the boxes there, and it's actually quite diverse. In fact, many of these species are very scarce in council's other reserves. This is Mornington Peninsula Shire Council. Well, he said they're not scarce or rare in all of the other reserves, but for an amenity park, this really stands out for the large number of indigenous plant species that are there. And going with all that will be lots of insects and so on. So it has some desirable properties. It also has the desirable property that it is very low fire hazard in the grassy areas. Even in the thickets, it's not super high fire hazard, and it does have some benefit in reducing wind speed. Windbreaks are really important for managing fire hazard. Now, to establish what the fire hazard was in these grassy areas, I did the usual thing that I do. It's a pretty standard sort of approach. I chucked a little square frame, 1/2 metre on each side, onto the vegetation, more or less randomly. And within that 1/4 of a square metre, I clipped all of the vegetation down to mineral earth and put all the stuff into a bag. Anything that's thicker than 6 millimetres, either a stick with a diameter more than 6 millimetres or a piece of bark that's thicker than 6 millimetres, that's not included. There's a standard, or there's a convention that you include fine fuel, being everything thinner than 6 millimetres, which is the old 1/4 of an inch. That's where it came from. And it's the thickness of a pen or a pencil. So you can rapidly assess whether a particular stick or part thereof is more or less than 6 millimetres. So I clipped all the stuff from the 1/4 of a square metre, put it all into a paper bag. You get down to the point where you can't possibly pick up more organic material without also picking up some mineral earth. So you end up at a balance point where you've left a bit of organic material, but you've also picked up a bit of mineral earth. And when you think that the mineral earth that you picked up is about the same weight as the vegetation that you're leaving behind, that's the point to stop. And it'll all recover. It's only 1/4 of a square metre, except that I took, I think, 5 replicates to get some statistical value from it all. And I'm seeing some trigger plants in there as well, now that I look, yeah. And then I take the plastic bags, shopping bags, back home, stick it in a microwave oven, dry it for a while and weigh it, dry it for a while, weigh it again and see whether it's dropped. Keep on doing that at intervals until either smoke starts coming out of the microwave oven. Don't try this at home, girls and boys. If there's any charcoal in your material, it will glow, I discovered. So be wary of charcoal, but you keep on drying it out until the weight does not change in successive drying. And at that point, you have what is called the oven dry weight of fine fuel for your 1/4 of a square metre. You multiply it by 4, and obviously that's 1 square metre. And then I think you divide it by 10 to scale it up to tonnes per hectare. And the numbers that I was getting were between about 2 and 5 tonnes per square metre. the fire brigade becomes concerned with surrounding houses around an amenity park. If it gets above, well, if it gets to about 8, you start to have a concern. If it's 12, then yeah, you really need to do something at that point, given our climate change conditions in particular. So in this case, it's half or less of the level at which a fire brigade would start to become concerned about the fuel loading. Now, so we've got all this vegetation that has conservation values and that the neighbours all really liked. In fact, to the extent that they would ask the council not to slash the vegetation until the wildflower display had finished. And in fact, until most of the seeds of the wildflowers had been shed, which is how I came to take these photographs. So the attractiveness of this vegetation was an important part of its conservation. It stopped the vegetation being mown so early as to stop the seeds of the native grasses and wildflowers setting seed or becoming ripe. So I think the attractiveness meant that the vegetation was managed in a way that allowed the natives to persist indefinitely. When I last went there a few years ago, it was still looking in really great shape. Council didn't know what they were doing. It was really by accident. Now, on the other side of the fence, there is this scene, at least there was, where these pine trees and some drooping she oak and all these weeds, it now has houses all over it. The reserve is off to the left there. You can see a wall of Banksias there. They're Banksias, and maybe that's a pine that had escaped from the pine plantation. So we've got an amenity reserve which the neighbours liked, and it has some conservation value. On the other side was a pine plantation, an asset that had to be had to be protected from the threat provided by this native vegetation. So a fire break was put around the pine plantation. In the fire break, well, some drooping she oaks had grown up, and here is a Banksia. A Banksia had managed to pop up, but overwhelmingly we see the golden colours and a certain green colour of sweet vernal grass, Amphoxanthin odoratum, and we see Watsonias, and it's really weedy. There is the odd Banksia which got slashed every year, and I can tell you that looking down in between the sweet vernal grass, there were some sundews, Drosera auriculata, but not very much in the way of native vegetation. And I also did that fine fuel loading assessment and found that this was 12 tonnes per hectare just before the annual slash, and occasionally this is ploughed as well. So this is a fire hazard. This does threaten the nearby houses, and it doesn't provide an effective protection for the pine plantation, other than that by the start of the fire danger period, it did get slashed and periodically cultivated, ploughed. So it required a heck of a lot of inputs in order to avoid fire hazard, but with none of the benefits for aesthetics or fire prevention that were being achieved inside the reserve with lower resources. So this tells us something. In fact, it tells us a few things, some principles that we can take away from this. Firstly, I think the cultivation that has happened along this strip has created weed problems that would not have been there otherwise. And I'll just see, I can't remember whether I've included, no, I haven't included another slide. These actually came from proper slides, Ektachrome slides that I took before digital cameras were a thing. And so I've had to convert them. I do have a slide which shows a little spot inside the reserve on the left there where one year, the tractor did go in before the wildflowers had set seed and so on. And because it was damper in this particular spot, the tractor got bogged and spun its wheels. And I came along afterwards and saw that there had been some, that the vehicle had been bogged, and up had come a dense mass of Yorkshire fog grass and other introduced grasses, but particularly Yorkshire fog. When I was giving a presentation like this to the council some years later, a bloke piped up and said, yeah, that was me. So what that tells us is that it's not that there's something intrinsically different about the soil type and vegetation in the reserve compared with here. In the reserve, it could become really weedy just by disturbing the soil, by spinning the wheels and operating a vehicle at a time of the year when the ground is boggy. So you never ever do that. Melbourne Water at Bungaluk Conservation Reserves. We'll see the results of that happening tomorrow probably at Bungaluk Conservation Reserves. So cultivation and disturbance of the soil can flip an ecosystem from a state where all of that web of interactions between the native flora and fauna gets completely upset, and introduced flora and fauna can take over, particularly the flora, and you end up with a weedy system like this. And you can maintain it in that weedy system if you get the timing wrong. This area that you see on the slide is just before the annual works are conducted, fire prevention works. And you can see that sweet vernal grass has already set its seed. And the Watsonias will have produced their bulbils for the year. So when the slasher goes through, they will be, well, they won't harm either the Watsonias or the sweet vernal grass, and they are the things that will come back in a big way the following year. So that's managed with timing that really suits the introduced species. And on the other side of the fence, the slashing is also done late enough in the season that any sweet vernal grass and other species like that will have set their seeds, but the natives have also set their seeds. And because it hasn't been cultivated inside the reserve, it's the vegetation is better able to resist the establishment of the introduced species. That's my interpretation of it anyway. So I think this example, well, it certainly gave me insight into how grassy ecosystems work and how they respond to different sorts of management and what to do and what not to do. Has anybody got any questions or comments on that example? $11:40. No, we're tracking well for time. I will give you another example about management. And this is in the Dandenong Valley Parklands. I did a project for Parks Victoria in which I marked out a series of plots in the same sort of way I described in response to Emma's example of the Banyule revegetation. In this case, the plots were 10 metres by 10 metres, and the treatments in some of them, well, the treatments were burning and use of Fusilade, which has been replaced by Fusilade Fort. That's one of those grass-specific herbicides with the active ingredient fluazethop. And in somewhere over in the middle distance in this photograph, for some reason I don't seem to have a photograph of the actual plot before it was treated, but it looks just like in the foreground here. I don't think this is the plot. Maybe it is. Anyway, it looked like this with lots of sweet vernal grass and large quaking grass. This was at the time soon after the students like John Morgan and I've forgotten her name, anyway, they had established in their student trials that use of Fusilade at the right time of the year, in early spring or late winter, at a low dose, could selectively remove large quaking grass and not knock native grasses or wildflowers, other than Poa morrisii, which is just temporarily set back and bounces back to flower normally for that year. So with Parks Victoria, we decided that that was worth trying in this weedy environment, which has a long history of grazing, but is now a park. And Parks Victoria thought, well, perhaps we can use either burning or Fusilade to remove the large quaking grass in large quantities. So at all these trial plots, and there's one in here somewhere where we marked out 10 metres by 10 metres, and I got the Parks Victoria people to calibrate their sprayers, as all good herbicide applicators should do, so that we applied the Fusilade Fort with some red marker dye at the on-label rate for annual grasses at the, I think at that stage it said the 3 to 5 leaf stage. So we looked at our large quaking grass and checked what stage they were at, and the right stage, the herbicide was applied with that marker dye. Here is a photograph of the actual plot in, I think it was about November after the spraying. October, maybe it was late October, somewhere around then. And you can make out a purplish sort of tinge or a purplish reddish tinge over this area, which is from the marker dye. And you can see the green of the large quaking grass and sweet vernal grass outside the plot. And it looks very different inside. I can see purple there, that's a chocolate lily flower. And there's its stem. Chocolate lilies were unaffected. There's Garnia radula, I expect, is it? It looks a bit like Garnia radula. That's certainly Garnia radula there. Garnia radula is in the sedge family. It's also really robust. It certainly didn't notice any ill effects. Some of these leaves are Trichorinia latior, the yellow rush lily. So again, in the lily family. There's also quite a bit of Lomandra filiformis subspecies Coriacea, the wattle mat rush that we've seen at both of our field sites so far, and we'll see some tomorrow too. I think that's probably what that is there, and they were unaffected. There's some Poa morrisii in here. Yes, it was knocked somewhat, but it certainly survived all right, and it did flower that year. We were thinking that this was a good result. In fact, I was ecstatic because not only is there no large quaking grass left in here, but there's also no sweet vernal grass. And there was, and there's still quite a bit of sweet vernal grass on the outside of the plot. And this was the first time anybody had noticed that the same treatment which deals with the large quaking grass will also get rid of the sweet vernal grass. And then I started to put two and two together and thought that although sweet vernal grass is a perennial, it's got that really shallow, fine root system. And I've learnt that it does rely heavily on each year's seed to get from one year to the next. So we can treat it very much as an annual species. So this is a demonstration that you can have really good success using a grass-specific herbicide. This is a Schedule 6 poison. So it's a level above chemicals like glyphosate, and that's because it has a higher environmental and human risk associated with it than a Schedule 5 herbicide such as glyphosate or clethodim. And I haven't done trials with clethodim. I've tried to persuade another number of councils and others to do so, and they've done trials that you wouldn't call scientific. So they've had experiences, and some of you in this group, I think, may have used those chemicals or clethodim. Was there somebody in this group who's used clethodim and gave us some information about it, or was that the afternoon group? I'm not hearing anybody, so it must have been the afternoon group. My experience, well, no, what I've been told from others is that clethodim can take longer than fusilade fort, and fusilade fort is not a quick-acting herbicide. It does take a while before you see the results, but clethodim, according to most of my contacts, it can be slower, but it must be somebody in the afternoon group, and I can't remember who, said that they found that both of them are slow and they hadn't really noticed any difference in the delay between spraying and when you see the results. But the two big advantages of using a herbicide with clethodim as the active ingredient are, number one, it's a Schedule 5 poison. So you don't even officially need an Australian Chemical Users Permit for commercial application, which includes farming friends groups and councils. But I just like the idea of using the minimum amount of toxicity when you apply chemicals or use chemicals anywhere in the environment. So it's lower toxicity, lower risk to you and the environment and everybody else. The other thing is that clethodim also kills Vulpia species, although I'm told that it's not super effective, but it does control Vulpias and it's on label for Vulpias, such as squirrel tail fescue. Whereas flurazafop, it's not on label because it's not at all effective on those. So you can use herbicides. As I mentioned, these trial plots included some that were burnt, and that was also very effective. I did follow-up surveys for a couple of years after this, and there was good regeneration in this environment that it had a long history of grazing, and some of the plots were even in orchards with the orchard rows and mounds still there. In each of them, Conidia prostrata or running postman came up in, not in huge numbers, but considering nobody had ever recorded the species anywhere in the Dandenong Valley parklands, it was quite exciting to find that these species had been in the soil for scores of years, just waiting for the sort of treatment, whether it be fire or removing the weeds. The fire was certainly more effective at regenerating pea family plants, such as the running postman. So you can use fire, you can use chemicals. I also discussed with you in the field that there is a technique called crash grazing that can work. And also slashing can be somewhat effective with some of these species. It can be effective with sweet vernal grass, not so effective with the Vulpia species because they just flower again much lower. Okay. Are there any questions or comments on this example? No? I can see I'm going to run out of time if I don't hurry up. Okay, here is a photograph provided to me by Doug Evans, who worked for the Department of Primary Industries at the time, back in 2004. This is on his property at Christmas Hills. On the left, he used fusilade at that low dose in autumn, and on the right, he didn't. You can see that the grass is denser there. It's a little hard. I'm having trouble at this time of the year working out what the species are, but yeah, I can see some flat leaf blades there, and I can see some seed heads that are definitely sweet vernal grass. Doug reported to me in words that on this side there was bugger all sweet vernal grass left, just native grasses and a few wildflowers and that sort of thing. On the right-hand side here, there's lots of sweet vernal grass. So he regarded this as a success. So there's another example demonstrating that you can use chemicals to selectively control sweet vernal grass. Okay, that's it for the management stuff. Are there any questions before I go on to more things about the structure of a grass plant and how to identify grasses?
Just the rates that you're talking about for fusilade, do you know what those were?
No, I can't remember, but you can look it up on that. Fusilade's been replaced by Fusilade Fort anyway, so whatever it was on that label won't be applicable today. What you do is you go to the label,
Yeah.
you will see that there is a row for knapsack spraying of annual grasses, and it might say in certain crops, but in Victoria that we have a little more liberty. We can extrapolate a little bit along as long as the use is generally consistent with what's indicated on the label. So you go to the knapsack label and it will tell you how many mils of Fusilade Fort per litre. Does anybody happen to know what that is?
You mentioned about a lower rate though. So
Oh, well, it's the minimum rate of all the rates on the label. It is the
that's
minimum.
similar. Okay.
So
I
that's
think
what
it's
I'm
2 mil per litre.
Say that again.
I think it's 2 mil per litre. The high rate is 4 mil per litre.
Okay,
Thank you.
good. Yeah, because Fusilade Fort you can use on something like cooch, which is pretty hard to kill with most herbicides, but it does effectively selectively kill grasses at that higher dose, even something like cooch. Any other questions or comments before I move on? No, okay. Now, I could use this slide. Yes, look, I'll start with this slide and then I'm going to swap over to another screen to show you something more in the notes. You will remember that we have seen in the field the common wheatgrass, Anthosacne scabra there. And you may have had a look at some stage at ryegrass. These are examples of inflorescences where the spikelets are attached directly to the central stem through the inflorescence, the part that we call the rachis. And so you can see here we've got the alternating spikelets and their glumes are attached directly to the rachis. Same sort of thing with ryegrass and a whole range of cereal crops as well. And we call this sort of inflorescence with the spikelets attached directly to the rachis a spike. So we've got both spikelets, little bits here, and the spike being the overall inflorescence. And last week at Montrose, we saw a somewhat similar thing with the forest wiregrass. And so that is like a spike, and we noticed that the spikelets were again alternating on two sides of the rachis, but the spikelets on close inspection had tiny little stalks, which botanists have decided is important enough to draw a distinction between what we call a spike and what we call a raceme. It turns out that there aren't that many grasses out of the roughly 440 wild grass species in Victoria that have spikes or racemes at the ends of their stems, but there are rather more of them that have spikes or racemes arranged like you see on the bottom left three examples here. I have shown you Paspalum dilatatum 2 weeks ago online, and I flexed each of these caterpillar-like branches, and if I looked really closely, I would find that, like the forest wiregrass, the spikelets, actually every second spikelet has a tiny stalk. The alternate ones have no stalk. So this is a raceme because some of the spikelets have got tiny stalks, and the spikelets in this case are not in 2 rows, but 4 on one side of each of these caterpillar-like branches. And after the seeds are shed, you're left with these bare branches and little glooms left behind on them. A similar sort of thing occurs in the windmill grass that we saw out at Toowoomba Vale. The spikelets are attached on the undersides of the branches, just like here, and each branch is itself now is it a spike or a raceme? I think in this case it's a spike with no little stalks on the spikelets, but really it doesn't matter much whether it's a spike or raceme, it's more of academic interest. And so in the identification key for grass genera that I've given you, it only asks you, is it one of those two kinds, a spike or a raceme, as opposed to the other kinds of inflorescences. So we've seen windmill grass and paspalum. Bothriocloa macra is redleg grass that Emma mentioned earlier, and silky bluegrass, Dichanthium sericium, is very similar and closely related. With those two species, along each of these racemes, every second spikelet has got a stalk or a pedicel, and the other ones are sessile, that is, without any stalks. And the ones with the stalks or pedicels don't develop a grain, so they are infertile. I think they produce pollen from memory, but what happens is, as the seeds ripen, a pair of spikelets, one of them with the pedicel, called the pedicellate spikelet, and the other one without a pedicel, called the sessile spikelet, break off together with part of the raceme rachis. We've got a rachis through this thing. And so the top part, about where I've got the cursor at the moment, that top part will snap off and you'll end up with a shorter branch. So what you find is that as the season goes on, these branches get shorter and shorter and shorter as these pairs of spikelets, each with a pedicellate and a sessile spikelet, end up until you get down to the bottom here, and then you've just got three little prongs there after all the other stuff has fallen off. So that's quite distinctive. I will show you another grass in this group of grasses that has racemes, but not single racemes, as we saw with the forest wiregrass, that arranged more like this sort of thing. So I thought I should introduce you to that sort of stuff. Now we must be getting very close to out of time. Is there any question on that before I wrap things up? No, I see it's 11:59. Oh, I thought I was going to finish right on time, but I'm not. I will just, I'm finding it harder to keep on time because the structure of this course is so different with the online teaching. Now, the reason I raise all of that and have gone through that is because in that key to grass genera in Victoria, there is this couplet 38, where it asks you whether on the one hand you've got a spike or raceme, or on the other hand where they're not spikes or racemes. And I've given you a description in words there and some criteria that you can use, but I really feel that it helps a lot to see some examples. So I'll show you at least one more example tomorrow. So that was the relevance of going through all that stuff. Now, in the notes with the kangaroo grass on the cover, at page 15, I'll draw your attention to the section on differences from other graminoid families. Tomorrow, I'm going to show you a whole lot of members of the genus Juncus. I'll show you a range of sedges, and I'll show you one example from the Restio family, because that's a really important family in heathlands and heathy woodlands. This section on page 15 and start at page 16 will give you some background on that and some additional information. But I will show you a whole lot of this stuff in the field. So that would be important for you to read if you're at all interested in being able to distinguish the different families of grassy plants. Now, identification of grass species. I was thinking that at this stage and in the last minute or two that I will spend with you, I should draw your attention to this section 3, which I've updated this year. I've tried to distill what I hope would be the best way of going about identifying a grass that you might encounter in the field if you don't immediately recognize it. I've emphasized with you at the start of each of our field trips that I try and get in tune with the environment, because that helps me build up my knowledge over time of what sort of plants occur in which sort of environments. And so when I'm looking at a plant, I'm thinking now, how wet is it here? Is this a heathland or is it a more fertile bit of vegetation? Because that narrows down what the identity of an unmown plant might be. So the habitat conditions is the first thing that I put there. Then I'm looking at the overall appearance of the plant, such as with the forest wiregrass. The first thing that struck me is it's scrambling up other plants. And if it's doing something like that, I'm thinking, I wonder if it's got branching. And then I see, yeah, it's got branching all over the place. So they're the sorts of things that I'd be looking at, whether it's very tall and that sort of stuff. I would be paying attention to the base of the plant, whether it's creeping, whether I can see the separate tussocks of the grass, or whether it just seems a more uniform sward, such as you get with weeping grass or brown top bent grass. Those things are important. Then I look more closely at the stems and I check whether they're branched, and particularly if there's no flowering material, I would be looking at the leaves to see if they're flat or rolled in at the edges, enrolled as they say. And if there's no flowering material, I particularly focus on that collar area in most cases. If I'm in any doubt as to whether it's a grass, I might be looking for ligules and checking whether the leaf sheaths are split, because one thing I didn't demonstrate with the Garnia radula last week is that the sheaths on a grass plant are at least the innermost ones will be completely tubular, not split. Anyway, so there's that. And then I look for some ripe material. As I've mentioned a number of times, it's always best to get some ripe flowering material. Well, not so much in flower, but in seed, because as the seeds mature, they develop kinks in their awns and their hairs stick out and things become much easier to see what a seed looks like and to work out what a seed is, because earlier in the season, if there are multiple seeds formed inside each pair of glooms, they will be tightly joined to each other. Often the base of each floret, the base of each floret will be clasped by the floret below, and so it can be hard to tell what is a seed because there will be multiple ones of them all clasping each other. So further on in the season, they start to separate into the individual seeds. So you know now how to look for the most ripe or the ripest material. And as I've just explained, it's important to look at the structure of the inflorescence and the branching in it and look for whether it's a spike or a raceme. And remember that many grasses have inflorescences that are so dense that you won't see the branching initially, and you'll have trouble working out what is a spikelet until you flex it, the bending of the inflorescence, and if necessary, the bending of each branch will reveal the little stalks, the pedicels, and the individual spikelets, and hopefully the individual seeds within them. And then we go about looking at the spikelets and each of the grass seeds within them. So that's probably all I need to talk to you about, because it then goes on talking about the use of the keys, which we will hopefully have time to do a bit tomorrow. Okay, and I'll leave you to read the rest of the notes. And if you have any questions, you can ask me tomorrow, but that's all the time we've got left in this course. These courses always seem to fly by. So try and read the notes if you have time between now and tomorrow, and then you'll have the opportunity of asking me any questions. Okay, any questions before we wrap up? No. Then let me stop sharing. Oh, no, it's not saying that it's sharing. Are you not seeing what I'm seeing on the notes?
Not at the moment.
Oh, I've stuffed that up. I clicked share screen, but I must have stuffed it up. I'm sorry. I was going through that the notes Yeah, so all of what I was just talking about, right, was this stuff up, is on page, no, it's section 2.6. So I'm sorry, I was going through all that. And, yeah, okay. Now, let's see. Nicole's asking, do you know where the heath bent grass is located at Gunwalk? So could we possibly have a look tomorrow? Don't know heath bent grass. It's probably something else, yeah, we'll talk about that further. Yeah, ask me tomorrow, Nicole. Now, other things for tomorrow are bring your key to grass genera, because we'll have a crack at using that. And please make sure you've got clean footwear to bring to this site of national significance. There are 2 extremely rare plants in the reserves, an orchid and a grass. I'll show you this extremely rare grass undescribed. So I'll ask you to clean your footwear. So bring your key to grass genera. And that's all I can think of in the way of preparations for tomorrow's field trip. Any questions or comments before we wrap up?
Are there some site-specific notes, like the last field trips that will be coming?
Yes, I sent them to you with in the email that had the notes for the first one. So you'd have to go back 2 weeks and you'll find it there.
Easy.
Yeah, if you find that they're missing, I don't think you will, but if you can't find that email or whatever, just send me an email and I'll send them through to you promptly.
Great, thanks, Graham.
Any other questions or comments? Then we are wrapped up. I'll look forward to seeing you tomorrow at 9 o'clock. Bye.
Thanks, Graham.
Thanks, Graham. See ya.